Welcome to the first deep dive on an AWS service. The first one is called IAM. So IAM stands for the Identity and Access Management. It is a global service because in IAM, we are going to create our users and assign them to group. So we've already used IAM without knowing. When we created an account, we created a root account. And it's been created by default. This is the root user of our account. And the only things you should use it for is to set up your account, as we'll do it right now. But then you shouldn't use that account anymore or even share it. What you should be doing instead is create users. So you will create users in IAM, and one user represents one person within your organization. And the users can be grouped together if it makes sense. So let's take an example. We have an organization with 6 people. We have Alice, Bob, Charles, David, Edward, and Fred. So all these people are in your organization. Now, Alice, Bob, and Charles, they work together. They're all developers. So we're going to create a group called the group developers, regrouping Alice, Bob, and Charles. And it turns out that David and Edward also work together. So we're going to create an operations group. Now we have 2 groups within IAM. Now groups can only contain users, not other groups. So this is something very important to understand. Groups only contain users. Now some users don't have to belong to a group. For example, Fred right here is alone. He does not correspond to any group. That is not best practice, but it is something you can do in AWS. And also, a user can belong to multiple groups. That means that, for example, if you know that Charles and David work together and they're part of your audit team, you can create a third group with Charles and David. And as you can see now, in this example, Charles and David are part of 2 different groups. So this is the possible configurations for IAM. So why do we create users and why do we create groups? Well, because we want to allow them to use our AWS accounts, and to allow them to do so, we have to give them permissions. So users and groups can be assigned what's called a JSON document. I'll show you right now what it means, called a policy, an IAM policy. So it looks just like this. So you don't have to be a programmer. This is not programming. This is just describing in, I think, plain English, what a user is allowed to do or what a group and all the users within that group are allowed to do. So in this example, we can see that we allow people to use the EC2 service and do describe on it, to use the Elastic Load Balancing service and do describe on it, and to use CloudWatch. Now we'll see what EC2, Elastic Load Balancing, and CloudWatch mean, but through this JSON document that looks just like this, we are allowing our users to use some services in AWS. So these policies will help us define permissions of our users. And so in AWS, you don't allow everyone to do everything. That would be catastrophic because a new user could basically launch so many services and that will cost you a lot of money, or this would be a problem for security. So in AWS, you apply a principle called the least privilege principle. So you don't give more permissions than a user needs, okay? So if a user just needs access to 3 services, just create a permission for that user. So now we have seen an overview of IAM. Let's go in the next lecture to practice creating users and groups. So let's go ahead and practice using the IAM service to create users in AWS. So in the search bar, I just type IAM and I go into the IAM console. So upon arriving on the IAM dashboard, we have some security recommendations that we can, for now, not care about. And what I want to draw your attention to is that on the left-hand side, we go to users. So this is where we're going to create users for IAM. But first, let's notice something. If you go to the top right corner and click on global, you can see that the region selection is not active. That means that IAM as an entire service is a global service, and therefore there's no region to be selected. When you create a user in IAM, it will be available everywhere. But some other consoles we'll see in this course will be region specific. So just something to notice. Okay, so now we have users. And why do we create users? Well, we create users because right now we are using what's called the root user. So if you click on this, you see there's just the account ID available to you. So when you have it, that means you're using the root account, and it's not best practice to use the root account. So therefore, we want to create users, such as admin users, that will allow us to use our account more safely. So for this, let's go ahead and create a user, and I will provide a username, for example, Stefan. So of course, I want to provide myself access to the management console. So I'm going to do this. And we have the option to use Identity Center, which is recommended, or to create an IAM user. I will choose the second option because it is more simple. And from an exam perspective, this is the one you need to know about. but don't worry, this does not affect how your course is going to go. Okay, so we create an IAM user, and now we have to set the password. So if this was a user that was not me, I would leave it as auto-generated password, and I would leave this so that the user must change this password at the next sign-in. But because it is me, I'm just going to enter a custom password, and I'm going to untick this because I don't need to change my password at the next login. So let's click on next. Next, we have to add permissions to this user. So we can add it directly, or we can get started with groups. So let's create a group, and we're going to create a group. The group name is going to be admin, and the policy name is going to be administrator access. So now that this is done, we can add the user into the admin group. So let's click on next, and we can review everything right now. So we have the username, the permissions on the group, and we have tags. And tags are everywhere in AWS. They are optional, but they allow you to give metadata to many of your resources. For example, I could say that the department of Stefan is engineering. This is not something I'm going to do everywhere in the course, but I want to show you once how you can add tags to resources in AWS. Okay, so now the user is created successfully. So now we can email signing instructions or download CSV files, and then we can log in with this user. But first, let's return to the user list and have a look at everything. So here is my user list. Here is me. And we also have groups. So if I go to the left-hand side, user groups, we have admins. So let's observe admins. So admins has one user in it named Stefan. And if you look at permissions of admins, you see that there is administrator access attached to the admin group. Now, if I go to my user Stefan in here, we can look at permission policies and see it also has administrator access. But this one has not been attached directly. It has been attached via the group admin. So that means that Stefan inherited any permissions of the group admin it is in. And this is why we put users in groups. It is a bit more simple to manage permissions this way. So now let's go back to our dashboard, and we want to sign in with our user Stefan. So first, what we can do is look at our AWS account, and it has an account ID and a signing URL. Now you can customize this signing URL very easily by creating what's called an account alias. So it could be AWS Stefan v3, and then create alias. So whatever alias until someone hasn't created it, so it has to be unique. For example, v5 is available. So now using this alias, I can simplify my signing URL. Now to sign in using my Stefan account, we could use the same browser, or we could create a new browser window in private mode. And the benefit of doing this is that we can have two windows side by side using AWS. So if you don't do this, that's fine. But if you log in using the Stefan account on the right-hand side window, then you will be disconnected on the left-hand side. This is the only difference. So to use two accounts at the same time, the root on the left and my account on the right, what I'm doing as a trick is that I'm using a private window on my web browser. And Chrome has this feature, Firefox has this feature, Safari has this feature, and so on. So by pasting the signing URL, as you can see, I get the sign in as an IAM user. And to get to this page, we can go back to one. And as you can see, when you do a sign in on AWS, you have the root user sign in or the IAM user sign in. So to get back to this, we go to IAM user. We enter either the account ID or the account alias that I can copy in here. And then we are taken to this page. So the IAM username is going to be Stefan, and the password is going to be whatever you have set from before. Then you sign in. So now the cool thing is that if I look at the top right-hand side, I am logged in using my IAM user. So it says the account ID and the IAM user. But if I look on the top right-hand side of here, it just says the account ID, which shows me it's the root account. So here we are. We have the root account logged in on the left-hand side through a normal window, and we have the IAM user logged in on the right-hand side through a private window. Please make sure not to lose your root account logins and your admin login. Otherwise, you will be in deep trouble with your account and you'll have to contact AWS for support. Unfortunately, I cannot help you with this. Now, from a course perspective, I recommend you use your IAM user and not your root user, but this is just a normal recommendation. Sometimes you'll see me using root, sometimes you'll see me using IAM user, but when you have to use root or when you have to use an IAM user, I will let you know in the course, so don't worry about that. Now for the rest of the section, please keep these two windows open, and I will see you in the next lecture. Okay, so now let's discuss IAM policies in depth. So let's imagine we have a group of developers, Alice, Bob, and Charles, and we attach a policy at the group level. In that case, the policy will get applied to every single member of the group. So both Alice, Bob, and Charles, they will all get access and inherit this policy. Now, if you have a second group with operations with a different policy, David and Edward will have a different policy than the group of developers. If Fred is a user, it has the possibility not to belong to a group, and we have the possibility to create what's called an inline policy, which is a policy that's only attached to a user. So that user could or could not belong to a group. You can have inline policies for whatever user you want. And finally, if Charles and David both belong to the audit team and you attach a policy to the audit team as well, Charles and David will also inherit that policy from the audit team. So in this case, Charles has a policy from developers and a policy from audit team, and David has a policy from audit team and a policy from the operations team. That should make a lot of sense when we get into the hands-on. Now, in terms of the policy structure, you just need to know at a high level how it works as well as how it is named. So this is something you will see quite a lot in AWS, so get familiar with this structure. This is a JSON document. And so an IAM policy structure consists of a version number. So usually it's 2012, 10, 17. This is the policy language version. An ID, which is how to identify that policy. This is optional. And then more statements. And statements can be one or multiple ones. And a statement has some very important parts. So the SID is the statement ID, which is an identifier for the statement, which is optional as well. So on the right-hand side is the number 1. The effect of the policy itself. So it is whether or not the statement allows or denies access to certain APIs. So in the right-hand side, this is allow, but you can see deny as well. The principle consists of which account, user, or role to which this policy will be applied to. So in this example, it's applied to the root account of your AWS accounts. Action is the list of API calls that will be either denied or allowed based on the effect. And the resource is a list of resources to which the actions will be applied to. So in this example, it is a bucket, but it could be many different things. And finally, not represented here, but there's a condition to which when this statement should be applied or not. And this is not represented here because it is optional. So going into the exam, you need to make sure that you really understand the effect, the principle, the action, and resource. But don't worry, you will see those along the way in the course, so you should be confident with them by the end of the course. That's it for this lecture. I hope you liked it, and I will see you in the next lecture. So now let's have a look at IAM policies in depth. So first of all, let's go into users. And as you can see, the user Stéphane is part of the admin group, and therefore it has administrator access permissions to AWS. That means that if I use my user Stéphane to go into the IAM console, so now I'm using my user, and then I go to the left-hand side and click on users, as you can see, I can see my user Stéphane, which is right here. So my user Stéphane is permission to do anything because right now it's an administrator. But what I'm going to do is that I'm going to the groups of admins, and then I'm going to remove my user Stéphane from that group. So by removing the user, which I've done right now, then Stéphane loses its permissions on the right-hand side. How do we make sure of this? Well, let's refresh this page. And as you can see, now I see 0 users, and I get an access denied, and it said that I don't have the permission to do IAM list users. And so therefore, because I removed my Stéphane user from the admin group, then I've lost permissions to look at users on the right-hand side. So let's try to fix this. So let's go into IAM, and we're going to go under users, find Stéphane in here. And right now, as you can see, Stéphane has 0 permission policies, but let's add permissions. So we can add permissions directly or create an inline policy. So let's add permissions, and this is going to be easier. And so again, we could add the user back to a group. That's not what we want. Or we could attach policies directly to my user. And so the policy I'm going to attach is going to be IAM read-only access. So this will allow my user Stéphane to read anything on IAM, which is what we want. So let's add this permission. And now this policy has been added. So back in here, let's refresh this page. And as you can see now, I can finally do my API call again and look at the Stéphane user in my users category. So I can view users, I can view user groups such as admin, but can I create a group? Let's try to create the developer group and then create this group. And as you can see, I cannot create it because I'm not allowed to actually create a group. I'm only given the read-only access on IAM, And so therefore, because I have read-only access, I cannot create groups. So this shows you that you can only permission users for what they're supposed to do. And of course, if I wanted to give access to create groups on the right-hand side, I would need to attach a bigger permission set, such as the IAM full access. So next, let's do something. So next, I'm going to go into the left-hand side under user groups, and I'm going to create a group. So this group is going to be called developers. And then I'm going to add the user Stefan in this group, and I'm going to attach whatever policy I can find. For example, Alexa for business, but it doesn't really matter. Just attach the first policy you can. And let's create this group. Okay, so this has been added. And finally, let's go into the admin group. And again, we're going to add users and re-add Stefan into this group. So now if we go back to the Stefan user, so let's go into IAM and look at the users and look at Stefan. I'm going to shut down this message on the right-hand side. So if we look at Stefan as a user, as we can see, we have 3 permission policies attached to my user. We have the administrator access that has been inherited from the group admin. We have this Alexa for business manage policy that has been attached via the group developers. And finally, IAM read-only access that has been attached directly. And so as you can see, I inherited different permissions based on how it's been attached. So now let's look at policies in detail. So on the left-hand side, let's look at policies. And first, let's have a look at this administrator access policy. So if we look at it, it's the permission that gave us administrator access to everything. And if you look at the permissions defined in this policy, as a summary, as you can see, this allows all the services in AWS. And this number can change over time. It doesn't matter. The course will be up to date. So all these services, for example, AppMesh or Alexa for Business or Amplify, they all have full access. So how is this permission defined? Well, if you click on JSON, this is the JSON form of this policy. And we can see that here we have allow, action star, and resource star. So star in AWS means anything. So it means we allow any action on any resource. And of course, allowing any action on any resource is exactly the same thing as giving administrator access to someone. So this is how it's been defined. If we have a look at another policy, for example, the IAM read-only access that we saw from before. So if we look at it, we see that IAM is authorized with full list and limited read. And if I click on it, you can actually have a look at all the API calls that has been allowed as part of this policy, which is very handy. But if we look at how this has been actually defined, let's click on JSON. And here we have the JSON document that shows how this has been defined. So the effect is allow. And then we list out the API calls that are being allowed. So we have this one, and then we have get star. So when you have get star, it says that anything that starts with get and then has something after is authorized. For example, get users or get groups. Same for list. So we have a list star, so list users or list groups. So by using a star, we encompass and group many API calls together. So all this is allowed on resource star. And so therefore, that summarizes what the read-only IAM access policy is made of. So this is very handy. You can also create your own policy. So let's create a policy. And we have a visual editor or a JSON editor. So if you have JSON, you can just very simply edit this and create your JSON document with this builder, which is very handy. Or you can use the visual editor. And for example, let's say IAM. We want to create stuff for IAM. And what action do we want to authorize? Well, we want to authorize list user. So we're going to take this and get user. So just 2 API calls. And as we can see, we have selected 1 out of 38 in list and 1 out of 32 in read. And then what do we want to authorize this on? So on all resources or only specific resources. So this is a very simple one, but as you can see, this builder is very handy. And when you click on next, you can have a look and say my IAM permissions. And then we create this policy. And if we have a look at the policy we created, we can have a look at the corresponding JSON and see that indeed through the visual editor, we allowed IAM list users and IAM get user on resource star. And then this policy we can attach to groups or to users and so on. So this is how you manage permissions in AWS. So now to just wrap up this hands-on, let's go to user groups and we're going to delete the developers group because we don't need it. And then I'm going to go into my Stefan user and I'm going to just remove this IAM read-only access that I had attached directly. So now Stefan only belongs to the group admin and it has administrator access. So of course, if I go back to my IAM console in here and I just look at users, as you can see, yes, everything is showing fine. So it is working correctly. Okay, so that's it for this lecture. I hope you liked it and I will see you in the next lecture. Now that we have created users and groups, it is time for us to protect these users and groups from being compromised. So for this, we have two defense mechanisms. The first one is to define what's called a password policy. Why? Well, because the stronger the password you use, the more security for your accounts. So in AWS, you can set up a password policy with different options. The first one is you can set a minimum password length, and you can require specific character types. For example, you may want to have an uppercase letter, lowercase letter, number, non-alphanumeric characters, for example, a question mark, and so on. Then you can allow or not IAM users to change their own passwords, or you can require users to change their password after some time to make your password expired. For example, to say every 90 days, users have to change their passwords. Finally, you can also prevent password reuse so that users, when they change their passwords, don't change it to the one that they already have or change it to the one they had before. So this is great. A password policy really is helpful against brute force attacks on your account. But there's a second defense mechanism that you need to know going into the exam. And this is the multi-factor authentication, or MFA. It is possible you already used it on some websites, but on AWS, it's a must and it's very recommended to use it. So users have access to your account and they can possibly do a lot of things, especially if they're administrators. They can change configuration, delete resources, and other things. So you absolutely want to protect at least your root account and hopefully all your IAM users. So how do we protect them on top of the password? Well, you use an MFA device. So what is MFA? MFA is using the combination of a password that you know and a security device that you own. And these two things together have a much greater security than just a password. So for example, let's take Alice. Alice knows her password, but she also has an MFA generating token. And by using these things together while logging in, she's going to be able to do a successful login on MFA. So the benefit of MFA is that even if Alice has lost her password because it's stolen or it's hacked, the account will not be compromised because the hacker will need to also get a hold of the physical device of Alice, that could be her phone, for example, to do a login. Obviously, that is much less likely. So what are the MFA devices option in AWS? And you need to know them going into the exam, but don't worry, they're quite simple. The first one is a virtual MFA device. This is what we'll be using in the hands-on. And so you can use Google Authenticator, which is just working on one phone at a time, or using Authy. So for Authy, you have support for multiple tokens on a single device. So that means that with the virtual MFA device, you can have your root account, your IAM user, another account, another IAM user. It's up to you. You can have as many users and accounts as you want on your virtual MFA device, which make it a very easy solution to use. Now we have another thing called a universal second factor, or UTF security key. And that is a physical device, for example, a YubiKey by Yubico, and Yubico is a third party to AWS. This is not AWS that provides it. This is a third party. And we use a physical device because maybe it's super easy. You put it on your key fobs and you're good to go. So this YubiKey supports multiple root and IAM users using a single security key. So you don't need as many keys as users. Otherwise, that will be a nightmare. Then you have other options. You have a hardware key fob MFA device. For example, this one provided by Gemalto, which is also a third party to AWS. And finally, if you are using the cloud of the government in the US, the AWS Gov Cloud, then you have a special key fob that looks like this, that is provided by SurePass ID, which is also a third party. So that's it. We've seen the theory on how to protect your account, but let's go in the next lecture to implement that. So I will see you in the next lecture. So we are going to first define a password policy. For this, click on Account Settings on the left-hand side, you will find password policy and you can edit it. So here we can use the IAM default password policy, which composes of these kind of requirements, or we can customize the password policy and force a password minimum length. We can also require uppercase letter, lowercase letter, a number, a non-alphanumeric character. We can also turn on password expiration to turn on, for example, expire after 90 days, or that a password expiration requires administrator resets, or we can allow the users to change their own password, or we can prevent password reuse. So this password policy can be edited directly from the IAM console, and that's the first part of security. The second part is around setting multi-factor authentication for your root account. So if you click on the account name and then click on security credentials, if you are logged in with the root user, you will see my security credentials root user. Now, there is a way for you to actually protect your root user, which is the most important account in your AWS account, and you can protect it by using multi-factor authentication. Now, just so you know, I'm going to do it and demonstrate how it works in front of you, but I've had students who locked themselves out of their accounts because they lost access to their multi-factor authentication device. As such, if you think you are running the risk of losing your iPhone or whatever, do not do this, okay? Just keep your phone with you, just watch my video, it will be good enough. If you want to practice along with me, you can as well, and you can also delete the MFA device after activating it. Okay, but let's go ahead and assign an MFA device. So I will call this one my iPhone because this is what I have, but you can name it whatever you want. Then you can select the type of MFA device. So it could be an authenticator app, which is something I'm going to use, but also it can be a security key or a hardware TOTP token. So I'm going to use an authenticator app because it will be virtual. And now we go into the setup of the app. So there's a list of compatible applications right here that you can find here for Android and for iOS that we know work well with AWS. And as such, I'm going to use the Twilio Authy Authenticator, which is an app I like. So what I have to do then is actually launch the app on my phone, and then you click on Show QR Code. So when you show the QR code, you need to scan this QR code directly on your phone. So for this, you add an account, you scan the QR code right here, and once scanned, it will add the account and start naming it. So I will just save this. This looks good. And then we get access to MFA codes. So there is first the first MFA code. So 301935. So this is a code generated by my iPhone in real time, and this code is going to change over time. And the reason why these two codes are asked by AWS is that it wants to make sure that the MFA device is set up correctly and that the codes are accurate. So the second code is 792843, and of course they will be different for your device. And once these two codes are entered, you click on Add MFA. And as you can see, we can register up to 8 MFA devices currently, and you can scroll down and see them right here on the list. So the multi-factor authentication MFA, one, it's called My iPhone, that's been created right now. So if you wanted to remove it, you can remove it, and so on. But so how do we use MFA? Well, now if I log out of AWS and I log back in, so I'm going to use my root account and my password. Now, after doing a successful login, I have the MFA code to enter. And so I open my app and enter the code that I see and press submit. And this way I am logged in. And this is perfect because, well, we had an extra level of security on our account. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So we have seen how to access AWS using the Management Console, which is the web interface that we've done so far in this course. But there are actually 3 different options to access AWS. So the first one is the Management Console as we've seen, and is protected by your username and password, maybe multi-factor authentication. Then there is the CLI, Command Line Interface. And this is something we will set up on our computer. And this is protected by access keys. And access keys are credentials we're going to download in a few seconds that will allow us to access AWS from our terminal. Then finally, there is the SDK, the AWS Software Development Kit, which is used whenever you want to call APIs from AWS from within your application code. And again, these will be protected by the exact same access keys. So how do we generate access keys? Well, we will do this through the Management Console, and users are responsible for their own access keys. And access keys from a user perspective, they are secret, just like a password. So if you generate your own access keys, do not share them with your colleagues because they can generate their own access keys as well. So really make sure that you treat your access key ID just like your username and your secret access key just like your password. You do not share them with other people. So when you go into the management console, you get access key, and there's a button to create access keys, and then it gives you the right to download it in the very second. And so, for example, here is a fake access key ID and a fake secret access key. And these, when loaded into my command line interface, would allow me to access the AWS API. And we'll do this in the hands-on in a second. So again, remember, I want to make sure that you don't have any security issues while doing this course or at work. Do not share your access keys. They are private to you. So if you're new to the cloud and programming and so on, or IT, then you might not know what's a CLI. So CLI stands for Command Line Interface. And the AWS CLI is a tool that allows you to interact with the AWS services using commands from your command line shell. So whenever you see some code where you type a command line and then it returns a result, for example, AWS S3 CP and so on, this is what we call the CLI. And we are using the AWS CLI because we start every command by the word AWS. Now, with this CLI, you get direct access to the public APIs of your AWS services, which is going to be very helpful in this course. And then using the CLI, you can develop scripts to manage your resources and automate some of your tasks. The CLI is open source. You can find all the source code on GitHub, and it is an alternative to using the AWS Management Console. I know that some people actually do not even use the Management Console. They only use the CLI, for example. So what's the AWS SDK now? SDK stands for Software Development Kit. And this is a set of library. This is going to be language specific. So you're going to have an SDK for different programming languages. And similarly, it will allow you to access and manage your AWS services and APIs programmatically. But this time, the SDK is not something that you use within your terminal. It is something that you embed within your applications that you have to code. So your application will have the AWS SDK from within them. It supports many different programming languages, such as JavaScript, Python, PHP, .NET, Ruby, Java, Go, Node.js, C++. All of that are programming languages. There's also the mobile SDK if you're using Android or iOS, and the IoT, so Internet of Things device SDK, in case you're using some thermal sensors or bike locks that are connected, all these kind of things. So to give you an example of what you can build with the SDK, well, the AWS CLI that we're going to be using in this course is actually built on the AWS SDK for Python named Boto. So that's it for this lecture. Now in the next lecture, we're going to practice setting up the CLI and dealing with access keys. So I will see you in the next lecture. Okay, so we are going to install the AWS command line on Windows. So for this, we do AWS CLI install Windows on Google, and this will give us the list link. And we want to install the AWS CLI version 2 on Windows, okay? This is the latest, and so we'll get up to date. It doesn't change much versus version 1. It's just some improved performance and capability, but the API is exactly the same, and there's also an improved installer. So I'm going to scroll down in here, and to install a Windows, when you can just simply use it, install it using the MSI installer. So I just click on this link to download the MSI installer. Then I'm going to run the installer. So it should be very, very simple. Now the installer is starting. I click on next. I accept the terms of the license, click on next, install, and then we wait for the installer to be done. Yes, I want to allow whatever this is doing. Okay, so the installer is now complete. I click on finish, and now I can go ahead and open a command line. So I'll do command line, command prompt, here we go, on Windows. And to be sure that it's fully installed, I just tap AWS -- version and press enter. And if you get a result like this, AWS CLI, a version that starts with a 2, then Python, Windows, that means that your AWS CLI is now properly installed on Windows and you're good to go. Finally, just note that if you want to upgrade your AWS CLI, then you just need to re-download that MSI installer and just rerun the install, and it will be automatically upgraded. But as soon as you have this output, you're good to go, and you can follow me in the next lecture. So see you in the next lecture. So let's install the AWS CLI on Mac. And for this, we're just going to go on Google and make sure to choose the link installing the AWS CLI version 2 on Mac OS. And then we're just going to follow the process. So we'll scroll down and see what they say. And here is how to install it. So we can just download a PKG file. And this will be a graphical installer. So you download the PKG file. Then you click on continue, 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 and you agree. Then you say, okay, install for all the users on this computer. Click on continue, and then click on install. And this goes ahead and installs the CLI on Mac. So we wait for everything to be done. The files are being written. Okay, the installation is now successful, and we'll move the installer to trash. And now to test this out, you open a terminal on Mac. So you just go ahead and type, for example, terminal, and this will give you a terminal app. Mine is called iTerm on Mac, which is also a free terminal you can use. And then you just type AWS -- version. And if everything is going well, then it should give you back the version of the AWS executable. So let's wait for a little bit. And we get the answer, AWS CLI 2.0.10. So that means that everything has been installed correctly. So that's it for this lecture. In case of issues, please have a look at this guide. It will have the answer for you. And that's it for me. I will see you in the next lecture. Okay, so let's proceed with installing the AWS CLI on Linux. So for this, I'll just Google it, and I will choose installing the AWS CLI version 2 on Linux because this is the latest one. And I'm going to scroll down, and to install the CLI, let's go to installing. We just have to run these 3 commands. So the first one is to get a zip file. So I'll copy this, go into a terminal, and then I will paste it. And here we go. So this has been pasted, and it is downloading currently the installer. The next thing you have to do is to unzip it. So I copy this command and paste it, and this will unzip my installer. Great. And the last thing is to run the installer as root. So I'll do sudo and then install. This should prompt me for my passwords, which I enter right now. And then the install should proceed. Now it says you can run user local bin AWS -- version, or there is simply AWS -- version if your user local bin is in your path. And there we go. The AWS CLI has been installed. As you can see, it says AWS CLI /2. And then you'll get a different version based on when you do this. And then you get Python and Linux and both, of course. So you're good to go. When this works, we can run any command on the AWS CLI, and you can go ahead with the rest of the lectures. If you get any issues, please read this, and this will tell you what's going on. And that's it. I will see you in the next lecture. So let me show you how to create access keys. So I'm going to click on my username, Stéphane, and I'm going to go under security credentials. I will scroll down, and I will create an access key. As you can see, there are some selection you need to do. And based on the selection I'm doing, for example, I want an access key for the CLI, AWS is going to have an alternative recommended. For example, for the CLI, it's better to use Cloud Shell, which I will show you in the next lecture, so don't worry about it, or to use the CLI v2 and an authentication through the IAM Identity Center, which I will not show you because it's a bit more complicated. So based on what you want to do, if it's local code, application running outside of AWS or in AWS, and so on, you will have some recommendation in the bottom. For now, we're going to use the CLI, and we will use these access keys. And we'll click here to say, I understand the above recommendation, and I still want to create an access key because it is important for you to understand how they are, how they work, what they are, and so on. So let's create this access key. And now this is the only time you'll be able to have access to the access key and the secret access key. So I will go back now to a previous version of that lecture where you see the old UI, but don't worry, nothing changes from that point on. The first thing I have to do is to configure my AWS CLI. So I'm going to type AWS configure. And then I am greeted with entering my access key ID. Very nice. I can just enter this one and press enter. And then I'm greeted with entering my secret access key, which I will enter right here as well. The default region name, so this is a region that is close to you. I will choose EU West 1 because I will be doing all my tutorials in EU West 1, but you will choose your own region and you can enter your own region name. That the region name, by the way, you can get directly from this drop down right here. It shows you the name of the region as well as the region code. So for me, I'm going to use my EU West 1. I'll press enter. And then the default output format, I'll just press enter as well. So now my AWS CLI is configured. And so we can have a look at how it works. We can do AWS IAM list users and press enter. and this will list all the users in my account. And as we can see, the user I have right now is called Stefan. Here is the user ID, here is the ARN, when it was created, and when the password was last used, which is very similar to what I would get if I were to go into this UI right here. So the management console and the CLI do provide similar kind of information. Next, I want to show you what happens if we remove permissions from our users. So I'm going to go to admins, and I'm going to remove the Stefan user from the group admin. And so again, if I go back to my user, Stefan, it doesn't have any permissions. And I did this obviously with my root account, not the other account. So now, if I go into my UI and obviously refresh this page, I'm going to get an error saying that yes, I do not have the permissions to do this. But let's try to do the same thing with the CLI. So we're going to do an IAM list user call, and we get no response because actually it was being denied. So the CLI permissions are obviously going to be the exact same as the permissions you get from the IAM console. So the takeaway from this lecture is that you can access AWS using the management console or using access key and secret access key that you can configure and then use into the CLI. So hope you liked it, and I will see you in the next lecture. And obviously do not forget to add your user back into the group, otherwise that would be horrible. So I'm going to go into groups, admins, and I'm going to add my Stefan user back into my group, and now I am an administrator again. So that's it. I will see you in the next lecture. Okay, so I would like to talk to you about an alternative to using the terminal to issue commands against AWS. And this is using Cloud Shell. So Cloud Shell is this icon right here on the top right corner of your screen. And if you don't see it, just make sure you check out the Cloud Shell availability regions, because it's not available everywhere. And so if you go to the AWS Cloud Shell FAQ, you can see that there are some regions that's not available. So let's have a look right now with the regions. Here we go. Question 3. Right now that I'm recording, it's only available in one of these regions. So by the way, I would recommend, if you want to follow along, to just use one of these regions then, so you can use Cloud Shell. But if you don't use Cloud Shell in this hands-on, that is completely fine. If the terminal was working for you, do not worry, you're good to go, okay? So we have Cloud Shell in here, and within Cloud Shell, it could take a minute maybe to launch your environment. You can issue commands. For example, you can issue the AWS command. So as you can see, it is installed. And if I do AWS - version, as you can see, I'm on version 2.1 right now using Cloud Shell. So Cloud Shell is basically a terminal in the cloud of AWS that's free to use, okay? So the cool thing about Cloud Shell is that whenever you are using the CLI, so for example, AWS IAM list users, this is going to return for you an API call as if the credentials being used were the credentials of the account of you using the cloud right now, which is why the API calls are working. And by default, you can specify any kind of region you want to do the API call using the -- region argument. But in Cloud Shell, the default region is going to be the region you're currently in, logged in right now in Cloud Shell. So this is another thing that's good to know. Okay, other things that you should know about Cloud Shell is that you have a full repository. So for example, right now, as we can see, we have 0 files within Cloud Shell. But if you just do echo test into demo.txt, this is going to create a text file that contains the word test. And so it turns out that if you happen to restart your Cloud Shell, then this file will stick. So all the files you are creating within your Cloud Shell environment, for example, this demo.txt, are going to stay. And the other cool thing you can do about Cloud Shell is that you can configure it. So you can say what font size you want, smallest, medium, large, and so on. The theme you want, so light or dark, if you want safe paste or not. So this is like a bigger Cloud Shell for me right now. And also you have the possibility to download and upload files. So for example, if I want to get the full path to my file, so this demo.txt, I can just copy it right now, action and download file, and then do demo.txt, and this will go ahead and download the file for me. And alternatively, you could upload your own files into your Cloud Shell environments. So I want to show you these handy options because for me, they are lifesavers, okay? And finally, if you wanted more tabs into this environment, you could have a new tab. You can split into columns, for example, and there you go. You have 2 terminals into Cloud Shell connected at the same time. So really, I want to show you the power of Cloud Shell in this hands-on. Again, you don't need to know all the commands I just did. I just wanted to show you, if you're a power user, that you could do these commands and how they would work with Cloud Shell. So the bottom line for this lecture, again, is number one, Cloud Shell is only available in some regions, so maybe try to choose one of the regions where Cloud Shell is available if you want to use it. If you don't want to use Cloud Shell or Cloud Shell is not working for you, this is completely fine as long as you use the terminal the way we configured it from before. This will work just fine, and you will be fine in the course to either use Cloud Shell or your terminal to perform the commands with the CLI against AWS, okay? And also remember that I really like the upload and download feature of Cloud Shell to the upload files and download files from it, okay? So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So we have to talk about the last component of IAM, which is called IAM Roles. So some AWS services that we'll be launching throughout this course will need to perform actions on our behalf on our account, okay? And for this, to do these actions, they're just like users, they will need some kind of permissions. So we need to assign permissions to AWS services, and to do so, we're going to create what's called an IAM role. So these IAM role will be just like a user, but they are intended to be used not by physical people, but instead they will be used by AWS services. So what does that mean? It's a bit confusing. So for example, we are going to create throughout this course an EC2 instance. An EC2 instance is just like a virtual server, and we'll see this in the next section. But so this EC2 instance may want to perform some actions on AWS. And to do so, we need to give permissions to our EC2 instance. To do so, we're going to create an IAM role, and together they're going to make one entity. And together, once the EC2 instance is trying to access some information from AWS, then it will use the IAM role. And if the permission assigned to the IAM role is correct, then we're going to get access to the call we're trying to make. So some common roles include what I just showed you, EC2 instance roles, but also other things that perform actions against AWS we'll see in this course, for example, Lambda function roles or a CloudFormation. So I know this is a high-level overview. In the next lecture, we'll be creating a role, but we won't be using it yet until the next section. But let's go ahead and create a role. I will see you in the next lecture. So let's practice using roles. So on the left-hand side, you click on roles, and you can see that some roles may have already been created for your account. Could be 2, could be more. It doesn't matter. But what we're going to do is that we're going to create our own role in here. So role is a way to give AWS entities permissions to do stuff on AWS. As you can see, you have different kind of roles you can create, actually 5 of them right now. But the one that you need to know about for this hands-on and for the exam is going to be a role for an AWS service. So let's choose this one. And then we need to choose for which service we want this role to apply to. So as you can see, if you click on it, you have commonly used services such as EC2 and Lambda, or a role for pretty much every service on AWS. So it's a very common thing to know in AWS, and that's why we learn about it. So we're going to create a role for an EC2 instance when we get to the EC2 section. And so we choose EC2, and the use case is just EC2. We disregard any of these. So let's click on Next. And now that we create a role for an EC2 instance, we need to attach a policy. So I'm going to attach the IAM read-only access to allow my EC2 instance to read whatever is in IAM. Let's click on Next. Next, we need to enter a role name. So demo role for EC2 is going to be my role name. And then we select the trusted entities. So this is saying, hey, this role can be assumed by the EC2 service. And this is what defines it as a role for Amazon EC2. We are verifying the permissions. Yes, it has IAM read-only access. And we create this role. So now my role is created. As you can see, it appears in my role list. And we can verify that the permissions are correct for this role. Now we cannot use this role just yet because we need to get to the EC2 section, but we will use it when we get to it. In the meantime, you've seen how to create a role for Amazon EC2 and how to attach correct permissions to it. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. We are nearing the end of this section, but first, let's talk about the kind of security tools we have in IAM. So we can create an IAM credentials report, and this is at your account level, and this report will contain all your account's users and the status of their various credentials. We'll be actually generating it right now and having a look at it. And the second security tool you can use in IAM is called IAM Access Advisor. This one is at the user level. And the Access Advisor is going to show the service permissions granted to a user and when those services were last accessed. And this will be very helpful because we are talking already about the principle of least privilege. And so using this tool, we're able to see which permissions are not used and reduce the permission a user can get to be in line with that principle of least privilege. So I will see you in the next lecture to show you how to use the security tools. So let's generate a credentials report. For this, on the left-hand side, I just click on credential report and then download credential report, which is going to create a CSV file. Now this CSV, because I'm using a training account, is not fascinating, but as we can see, we have two rows in it. We have my root account and my account named Stefan. We can see when the user was created, if the password was enabled, when the password was last used and last changed, when is the next rotation to be expected if we do enable password rotation, is MFA active, so we can see it's active for my root account, but it is not active for my Stefan account. Then access keys, are they generated or not? Yes, they're created for my Stefan account, but not for my root account. And when were they last rotated, last used, and so on. You can get more information about other access keys and certificates and so on. So this report is extremely helpful if you want to look at some users that haven't been changing the password or using it or their account. It could be really giving you a great way to find which users that deserve your attention from a security standpoint. Now let's have a look at IAM Access Advisor. For this, I'm going to go to my user, Stefan, and then on the right-hand side, I click on Access Advisor. And Access Advisor is going to show me which services were accessed by my user and when. So as you can see, organizations, health, IAM identity and access management, which is IAM service, EC2, Resource Explorer were all accessed by my user. So I use my user to access these things by clicking in the UI. But some services were not accessed. For example, Alexa for Business or AWS App2 Container and so on. So using Access and Advisor, you can actually have a look at whether or not the user has the correct permissions. And it turns out that maybe based on this access, I have 37 pages of this, maybe the user needs access only to a few services, but not all of them. And this UI allows you to drill down. On top of it, if a user accesses a specific service, for example, Amazon EC2, we are told that this is the administrator access that granted access to the service. So to summarize, Access Advisor becomes very helpful when you need to do granular user access permissions on AWS. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture. So here are some general guidelines on IAM and best practices, because I don't want you, if you go to use AWS, to make some mistakes. So do not use a root account except when you set up your AWS account. So by now you should have two accounts, a root account and your own personal account. And remember, one AWS user is equal to one physical user. So if a friend of yours wants to use AWS, do not give them your credentials. Instead, create another user for them. You can assign users to groups and assign permission to groups to make sure that security is managed at the group level. And you should create a strong password policy. Also, if you can, use and enforce the use of multi-factor authentication or MFA to really guarantee that your account is going to be safe or safer from hackers. Then you should create and use roles whenever you're giving permissions to AWS services, and that includes EC2 instances, which are virtual servers. If you were to use AWS programmatically or using the CLI, so the CLI or some SDK, you must generate access keys, and these access keys are just like passwords. They're very secret, so just keep them for yourself. To audit the permissions of your account, you can use the IAM Credentials Report or the IAM Access Advisor feature. Finally, never ever ever share your IAM users and access keys. I am very serious about it. So that's it. We are nearing the end of this section. You know everything about IAM. I will see you in the next lecture. Throughout the CCP exam, you're going to get a lot of questions on something called a shared responsibility model. And this is to ensure that you know what AWS is responsible for and what you are responsible for. Now, I wanted to include some bits of information within some sections to give you an idea of how the shared responsibility model works for AWS. So AWS is responsible for everything that they do, for example, their infrastructure and their global network security, the configuration and vulnerability analysis of the services they offer, and any sign of compliance that they are responsible for. But regarding IAM, you are responsible for a lot of things that AWS will not do for you. You are responsible for creating your own users, your groups, your roles, your policies, the management of these policies, and the monitoring of that. You are responsible for enabling MFA on all accounts and enforcing this, not AWS. You are also responsible to make sure that the keys are rotated often. You need to make sure that you use the IAM tools to apply the appropriate permissions. And again, you are responsible for analyzing the access patterns and review the permissions in your account, not AWS. So this is a very simple example, but an obvious one, but AWS is responsible for all the infrastructure and you are responsible for how you use that infrastructure. This is just one of these lectures on shared responsibility. I hope you liked it and I will see you in the next lecture. So here is a summary for IAM. We've seen IAM users and they should be mapped to an actual physical user within your company, and this user will have a password for the AWS console. Now we can group these users into groups and therefore users only. We can attach policies or JSON documents that outline the permission for users or groups. And we can also create roles, and these roles will be identities, but this time for maybe EC2 instances or other AWS services. We've seen that for security, we can enable multi-factor authentication, so MFA, and also set a password policy for our users. We can use the CLI to manage your services using the command line, or the SDK to manage your AWS services using a programming language. Finally, we can create access keys to access AWS using the CLI or the SDK. And finally, we can audit our IAM usage by creating an IAM credentials report and also using the IAM Access Advisor service. So that's it for this lecture. I hope you liked it, and I will see you in the next lecture.